Okay, I'm going to show you how to make a plot that looks like this. It's a phylogeny with a heat map that's matched to the phylogeny according to some data frame that you have. So we're going to build it from scratch very simply. So one way to get the phylogeny is, well, the phylogeny uses a nexus file, and there's a website which I'll use called birdtree.org, and it has these phylogenies that can be made from different species. So you just put in the species name here, and then you give your email address, and you pick a particular type of phylogeny and the number of trees that you want produced, and it'll email you the nexus file. And then you'll want to go into R. Let me just remove this stuff. Okay, so in R you need to load it. You need to load the phylogeny. So this uses the ape package. Okay, so we'll load the ape package, and then we will read the phylogeny, which you received in your email. It's a nex file. I've just put it on the desktop, but it's just in the folder you receive. It'll just be called output. And you can see this is a list of many phylogenies, and we only need to use one for the purposes of this exercise. So just to show you this, you can see the structure of each phylogeny has these different components: the edge lengths, tip labels, which are the species names. So we're just indexing this to look at the first one. You see this, it gives it a tree number, so it's $tree 1140. Okay, so we can just plot that specific tree. We can either index the first one. Let's see. Yeah, so this is the phylogeny that I got. For the specific species, this is a bunch of ducks. And okay, so that's how you get the phylogeny in. And now I want to create the data frame. And so what I want to do is index this specific tree. I just want to get the list of species names. So I'll index that tree and its tip label object. And then there's a write clipboard function which will allow me to copy it to the clipboard. And then I will, well, I was doing this in Excel already. Then you can just, you can just paste in there. I've just created a data frame with 4 variables and random numbers. You can use a random number generator here. And we'll save this as a data frame, save it as a CSV. Let's call it df ducks for heat map, and save it as a CSV. Sure. Now we need to import that. So we'll use read.csv, and we called it df ducks. Now let's just look at it. You can see we have our species, and I just like to note, if you it really has to be labeled with that underscore in between. It has to be labeled exactly as how these tip labels are formatted, otherwise you're going to get an error if your data frame doesn't have the species in the first column. So that's important. Then we need to plot these. We'll use two other packages, ggtree and ggplot2. Okay, and then we use a ggtree function. So here's the part where it links the data frame object and your phylogeny. So you can look at how this function works, but basically this is you're telling it which phylogeny to load. You can add aesthetic parameters according to the ggplot rules of graphics. But then this is the operator that's going to link your data frame. So that percentage sign, less than, plus percentage sign, and then you link your data frame after that. And then you can add all your other graphing parameters. Okay, so and then the this sort of sets the canvas X limit. You can also set the Y limit, and then the tip label will just write the species names. So let's give that a try. So this will that plots the phylogeny again. It was simple. It's just the same as the basic graphics plot. But now we need to add the heat map, which just it just uses the heat map function that's already built into ggplot, but it's more it has a way that it links it into the phylogeny species names in the ggtree package. So so for our heat map, we just want to add these values that we computed. So that would be from the df data frame, that's the 2nd through the 5th columns. So so we only need this 1 through 4. And this species is just going to be the link. But importantly here, okay, so let's just make that heat map as a new data frame. And then just to show you that it's removing the species column. But now we need those species, right, to link it to the phylogeny. So the way that it connects it is with is by setting the row names as the species names. So if you use the row names function, now this heat map data frame doesn't have row names as species. So what we need to do is specify the row names as the species. Okay, so then we do that by saying row names heat map is equal to the first column of the df data frame. So just to show you the df data frame, those are all the species names. So let's do that, and then we can see. Let's just check what row names heat name is now. Now it's the species names. Okay, now there's the heat map function is gheatmap. Just the inputs are the previous ggtree object that you had, which I called P, and then your heat, and then your data frame with those species names as row names. some offset, because if you don't use the offset, then it'll plot the heat map like right at the top of the names. And then this scale fill gradient is just coloring the values according to some spectrum. This is, you can look up that function in the general ggplot documentation. Okay. And then it nicely just adds your heat map to your phylogeny, maintaining the rows, the species rows with the data. And then you can save however you like. So I hope that was helpful. Cheers.